All right, let's jump right in. What if I told you there's a new theory in physics that claims it can build our entire universe? I'm talking all the forces, all the particles, from just a single, perfect geometric shape. No tweaking, no tuning dials, just pure, simple structure. Today we're diving into unified dynamics.
So here's our roadmap. First, we're going to talk about the problem this whole theory is trying to solve, this idea of a zero-dial universe. Then we'll meet the geometric seed at the heart of it all. We'll see how that geometry supposedly becomes physics, check out its three biggest predictions, see what else it can do, and then we'll ask the most important question of all. How could we prove it's wrong?
Okay, let's set the stage. The central problem unified dynamics is trying to wrestle with is all about the fundamental constants of nature. The very numbers that define the universe we live in.
I want you to imagine something. What if the universe wasn't some crazy complicated machine with dozens of knobs and dials that physicists have to carefully tune just to make the math match what we see outside? What if the machine came with no knobs at all? What if the rules were locked in from the very start by something much, much simpler?
And this brings us to a really crucial idea in physics, free parameters. These are basically numbers, like the mass of an electron or the strength of gravity, that our best theories, even the standard model, can't actually predict. We have to go out, measure them in an experiment, and then plug them into our equations. The standard model of particle physics has something like 24 of these dials. Unified dynamics boldly proposes a universe with zero.
So if there are no dials to turn, where do the laws of physics actually come from? Well, the theory gives a pretty radical answer. Everything emerges from one single, simple geometric starting point. That's it. That's the one and only assumption.
And here it is. The proposed seed of all of reality is the tetrahedron, the simplest possible 3D solid. The core claim here, and it's a huge one, is that everything, from the tiniest quark to the force of gravity holding you in your seat, is just an emergent property of the relationships inside this one perfect shape.
And just look at how simple it is. 4 points or vertices, 6 lines or edges connecting them, 4 triangular faces. You could build one with toothpicks and marshmallows. And yet, this theory argues that these few simple properties are all you need to bootstrap an entire universe.
So you have to be asking, why this shape? Why a tetrahedron? Well, it turns out it's not a random choice. A key theorem in the theory shows that the tetrahedron is mathematically unique. Its internal symmetries break down into dimensions of 1, 2, and 3. And here's the kicker. That 1, 2, 3 pattern is a perfect mirror of the mathematical structure of our universe's fundamental forces, what physicists call their gauge groups. It's not a coincidence, it's a direct geometric reflection of reality.
Okay, so we've got the shape, but how does an abstract piece of geometry turn into the concrete physics we can actually observe and measure? The answer, according to the theory, is something called the universal structure theorem.
This whole thing works in 3 steps. First, the pure geometry of the tetrahedron acts like a perfect blueprint. It sets all the ratios between physical constants. It's like it dictates that one force has to be exactly X times stronger than another, no exceptions. Second, a blueprint isn't a building, right? You need to set the scale. So for each major area of physics, all we need is one single measurement from the real world. Third, and this is the amazing part, with just 3 of these scale inputs, the entirety of physical reality is locked in.
And here are those 3 sectors and their single inputs. To set the scale for all the forces, you only need to measure one thing, the fine structure constant. For all the fundamental particles, like the electron, you just need the electron's mass. And for gravity, you just need g, the gravitational constant. That's the deal. Measure those 3 things, and the geometry of the tetrahedron supposedly predicts everything else.
Okay, this is where it gets really exciting. A theory that makes claims this big needs to make some bold, testable predictions. So let's look at the big 3 results that just pop out when you put this geometric structure to the test.
First up is the strong nuclear force. This is the incredibly powerful force that glues protons and neutrons together inside an atom's nucleus. The theory doesn't just estimate its strength, it derives this exact beautiful mathematical formula for it, purely from the geometry of that tetrahedron.
And just look at this. The value predicted by that simple fraction is 0.1167. The value that we've measured over and over in experiments is 0.1180. That is an error of just 1.1% from a calculation that had 0 dials to tune. That's pretty wild.
Next up,
we have the electroweak force, which is the unification of electromagnetism and the weak nuclear force. A key number here is the weak mixing angle. And again, the theory predicts this almost comically simple fraction, 3 divided by 13. This number dictates exactly how those two forces blend together.
And this one is even more impressive. The predicted value is off by only 0.19%. That's less than 0.2%. For a fundamental constant of the universe to be predicted this accurately by a simple geometric ratio, well, that's the kind of thing that makes physicists sit up and take notice.
The whole philosophy behind these results is kind of captured in this quote from the source material. The idea is that the universe starts from nothing. The field is zero. It operates by a simple repeating rule, a recursion, and the stable physical reality we see all around us is simply the fixed point of that rule. It's the one outcome that doesn't change.
And this brings us to the third big result, the master equation. Think of this as the engine of the whole theory. It's a recursive process called omega zero. Now, if you apply this process to any geometric shape, it'll change it. But there is only one structure that remains perfectly stable and unchanged by this process. You guessed it, the tetrahedron. It is the unique geometric bedrock that makes the whole structure possible.
But the theory's power doesn't just stop with those 3 big results. This same geometric model expands its reach into other fundamental areas of physics, and honestly, in some equally surprising ways.
Right from its first principles, the theory naturally derives that gravity has to be attractive, not repulsive. That just falls out of the math. It also predicts the mass ratios between the 3 types of lepton particles, the electron, the muon, and the tau, with incredible precision. And it even derives a value for the CP phase, which is a crucial number for explaining why our universe is made of matter and not antimatter.
And when I say the precision for those lepton masses is incredible, I'm not kidding. Once you put in the electron's mass to set the scale for that whole sector, the theory's geometric ratios predict the masses of the other 2 particles with an error of less than 1/100%. That's just astonishingly accurate.
So we have this compelling story, and we have some pretty mind-blowing results, but this is science. And the most important quality of any scientific theory isn't about being right, it's about being testable. In other words, how could we know if it's all just plain wrong?
This is the principle of falsifiability. A real theory has to stick its neck out. It has to make a concrete prediction that if an experiment comes along and shows it to be wrong, the whole theory comes crashing down. No wiggle room, no excuses.
And Unified Dynamics has a clear primary falsifier, a complex computer simulation known as the F6 lattice. The theory makes a hard prediction. If you simulate its fundamental rules on this lattice, stable, particle-like structures must emerge from the chaos. If they don't, if the simulation only ever produces noise, then the entire theory is wrong. It's an all-or-nothing test. Which leaves us with a final fascinating question. Could it all be true? Is our vast, complex universe really built from the elegant geometry of a single perfect shape?